Hello, and this is going to be the first video that you see before you see the actual main content for episode 8 coming up shortly. The I wanted to do this post-recorded video in editing just to basically emphasize the fact that it's taken me quite a while to edit this video. Now, this video actually cost me about an hour and 20 minutes of my time to actually record. Now, when you take into consideration how much time it then takes to actually edit the video and remove any of the babble that I tend to go on and all of the redundant sort of content that isn't really content but doesn't really go anywhere. One That's the sort of content that I'm trying to remove from the video. And with how little time I've got in my free time, I'm finding that this format is just not really working, at least in terms of actually producing the number of videos that I want in any given week. So, in order to fix that, I was potentially thinking of producing videos in a more of a scripted format, more bite-sized, shorter videos, so that it's potentially more approachable and also is content that is actually relevant. So I'm not just pausing when I'm talking, I'm actually talking almost effectively constantly throughout the video, and it's more scripted as well. So it means that there's no interruptions, there's no trying to work out exactly what to do next. Now, naturally, I'm actually quite good with just speaking on the fly. This is what I'm doing right now. I'm not reading a script at all. I'm actually just looking at Cyberlink. So naturally, I mean, obviously, I've been doing this for many years now. I've done tutorial videos on programming. I've done lots of different kinds of videos across multiple different channels. So I've had a lot of experience working with video content. So naturally, I'm actually quite good with trying to keep up with my own voice and thinking on the fly in this scenario. So it's not so much the case that I can't speak relatively quickly and give information out. It's simply the case that when you're programming, having to think while programming and also thinking on the fly at the same time in order to actually get your voice out there and your message out there is quite difficult to do, as you can imagine. It's very, very difficult to do programming and video recording at the same time because both things require thinking and it's actually quite difficult to achieve. I just happen to be quite a natural speaker in front of a camera, it seems. Not necessarily a live camera, but a camera nonetheless. So, to basically make it plain and clear, I'm thinking of changing the formula. You might not necessarily agree with it, but it seems best in the circumstances that I face at the moment. This video has taken me far too long, and I also don't want this intro to go on too long either. So, without further ado, let's get started with the episode. Hello and welcome to StoryDev. My name is Luke, also known as Tianery, and we are on episode 8 of Story Creator. I am not making that mistake again. Maybe, I mean, I did technically say in my previous video whether I should mention the episode numbers, but we're definitely on episode 8. I'm pretty sure of it. You've probably noticed in a couple of videos when I've scrolled past this point, emotion happy was here twice. I've fixed that now. I did notice it when I was editing the videos, so that has been fixed. And if we take a look at what we've got so far, we have, when it eventually loads, the ability to move our player, and anytime we move it, the player moves. and sorry, every time the player moves, the enemy moves. So what do we want to do now? Now, what we kind of need to do, or what I'd like to do, is actually implement a way to move within a specific range. And obviously we're going to have to detect if there's obstacles in the way to prevent us from moving over certain things, in order to expand our turn-based system. So how would we go about doing that? Well, we're effectively going to be doing what's called a scoring system in order to determine how we would go about doing that. Now, I'm actually going to delve straight into the code before I even start explaining things. So what I'm going to do in order to get the ball rolling is we are going to say function calculate available tiles. That was it. Calculate available tiles, and we want index. That is the index of the tile that we're currently in, followed by the step count, so the number of steps that we're going to iterate through. Now, what I want to be able to do is basically we've got an index where we want to start from a specific tile, and depending on what our step count is, we're going to move out from that tile into adjacent tiles that we can move into, and then increment the amount of steps until we get to the step count value here, and then we stop. So in order to do that, what we're going to do is we're going to have a result that we're going to get back from this function, and that is going to be an array of integers. So I'm going to say array int, and this result is going to contain the indices that will become available for us to move into. We also need our step, our current step. So that's going to start at 0, and our step count is, it needs to be greater than 0, basically. So if step count is less than or equal to 0, then we're just going to return null. Yes, I know. Return result. It's complaining that nothing is being returned in this scope because it has seen return null. It's inferring some type, but it doesn't know what the type is. Now that we've got that, obviously it's got a question mark there because it doesn't really understand what it's supposed to be returning at this point in the compiler. Once we get to here, the compiler then infers that this function returns an array of int. So once we've got this, we've got our current step. So what we want to be able to do is basically say while our current step is less than step count, we are going to iterate over our result to first see what indices we haven't been into yet, or rather what indices we have been into. So in order to do that, what we're going to do is we can obviously move up, down, left and right from any given index. So how is that going to work? We have the ability to move left, right, up, down, and we need to basically go through this meditation grid to determine what our current index is and what the next index would be, and then looking into that index and seeing if we can indeed move that in that direction. If we're yeah, let's see. Actually, also thinking about it, what I also would like to do is actually see effectively what the score is. So we want to keep track of what indices have what score. So we're also going to say result score is equal to new array int I'm not gonna do a map in this instance. I'm just gonna have two arrays. So if result.length is equal to 0, then we're starting from scratch basically. So what are we gonna do? We are going to see if we can move left, right, up, or down, and that will give us back our tile Y. So now what I want to do is basically see if we can move up, down, left, or right. So in order to do that, what I'm going to do is I'm going to say if tile X in here, index -1 dots. So if this is greater than 0, or rather is equal to 0, I should say, and we also want to see if our meditation state entities, so if that's equal to -1, in which case we don't find any entity that exists within this index, and we also find that the grid cell is empty, in which case there's no obstacle there other than an entity, then we can move in. So in that case, what we're going to do is we're going to say results.push. I'm going to say index -1 so we can move in. And also in here, I'm going to say push is equal to result score, I should say, sorry, is equal to current step. So we're not at the current, we're not at the next step yet. Now I'm going to basically copy and paste this because we're going to do the check for everything else. So A. So assuming that's all good, and we're going to leave it like that for now. Let's see. So if we then increment current step by 1, which is what we would do in this case, I'm just going to do this for now, and we'll go back to this. So this is kind of a to-do area. I just want to make sure that this code here actually does what I would like to see it as. So available tiles is an array of int. Oops. So any time we move, I want to recalculate available tiles. Meditation state dot available tiles is equal to calculate available tiles. Our index is our what is it? Player entity dot index, and then our step count is player entity dot max move. And I am, in fact, I'm not going to put it here. I am going to put it oh a minute. Well, there. That should be an else if. Oops. That shouldn't have happened. That shouldn't have happened. Well, we want to make sure we've definitely pressed something. So player input is equal to false. So I'm just going to say player input equal to true. Player input is equal to true. Just do the same thing over and over again. Why not? Sounds like a good idea. And down here, I'm going to say if player inputs, do that. Okay. So, we've got available tiles now. So what are we going to do with those available tiles? Well, I'll tell you what we're going to do. I will tell you what we're going to do down here somewhere. Let's see. We've got our index here. We've got meditation grid X and grid Y. Let's not do it here. Got entities here. Kind of want to do it in between, I think. Actually, no. Below. Below everything. So this is the grid. Highlight available tiles. What I'm going to do is if meditation states dot available tiles equal to not equal to null and its length greater than 0, then no, I don't want to do that. I want to iterate over those cells. Meditation state available tiles. Gonna grab the index of each of them, and we are basically just going to say our tile X is going to be the same as what we had before, which was up here. So we knew our tile X and tile Y, so we're going to do the exact same thing. Copy. Paste. And then I am going to do what we used to do, meditation cell size. Y times equals meditation cell size. And finally, we're going to draw it. Color dot from floats. I'm going to make this light blue, or don't do that, please. And then I'm going to give it a bit of transparency as well. And in here, I'm going to say fill rect is going to be tile X plus grid X, tile Y plus grid Y. Meditation cell size, meditation cell size. What did I do? Get rid of that, please, thank you. Where were we? Here. Right. There's also one other thing that we don't do, and that is to calculate it when we load into the game. So when we first enter the game, we want to load it. So we create our entities here, and we set that all up. So down here, I'm going to say meditation state dot available tiles is equal to calculate. And then we've got our player yeah, we've got a player index, haven't we? So let's say oh god, meditation state entities player index dot index, and then we're doing the same for the step count as well. Let's just bring that out here. Player like that. Max move. All we want to do is basically see something on the screen that vaguely resembles exactly what we want. Okay, let's have a look. It's probably not 100%, but we'll have a look. Okay, I've got something. I can technically move down now. I don't know why it's done that for. Oh, I've done something wrong. looks like. But in theory, no, that's good. Oh, no. Okay. Okay, that's interesting. It's appearing here, which is not what I want. Ah, it needs to calculate as if I've already moved into the square. That's a good point. And I think I've also done one of the calculations wrong. Let's see. Yes, I have. That was supposed to be index plus meditating grid X. Okay, so we've got to do this as if we're about to move into that cell. Instead, what we could do is move this outside of here. Player input is equal to false. And once we have player input, instead of doing it here, we're doing it here. And that way, we have calculated all of the movement of all of the entities that exist and then doing the calculation, which is what we want. Okay, let's have a look at that. Oh, what have I done wrong? Unknown identifier player entity. What am I doing? Oh, I kind of need that, didn't I? Mm-hmm. Mm-hmm. I'm just going to do this. Player entity equal to meditation state dot entities dot find e dot type is equal to entity player. All that. What? I'm confused. Maybe it's still thinking. Yeah, that's fine. Tax being weird. Okay, that's showing in the right place. So that's good. Let's see. Um, okay, that's weird. Okay, so we've still got a bit of an issue there. It's kind of annoying that we can't try and get this working properly. Yeah, it's kind of odd. I mean, I don't think it's quite. I mean, why is it? I don't understand why it's not. Why it's doing that for. Okay, now that's a bit of a problem, and that's why that's causing that issue. Why is that happening then? Is it because we're waiting until the next frame before that effectively happens? Yeah, that's the issue. We're waiting until the next frame because we're calculating this before the next frame rather than after. So what we need to do is wait. So if we've done player input, then we also need to make sure that our turn is okay. So let's have reset tiles ball, or reset available tiles, should I say. So I'm gonna have this reset available tiles as equal to false. Actually, no, we'll make it true initially. And what I'm going to do is in here, I'm going to say if player input and actually, no, not. I'm going to say meditation state dot reset available tiles is equal to true. So then what I'm going to do is when I go back into this function on the next frame, I'm going to check to see if meditation state dot reset available tiles is true, in which case do this calculation and then make it false. Yeah, see where I'm going? So in theory, that should fix the issue. Oh no, no, it hasn't fixed it. What? I don't understand why that would be the case. Oh, we can actually clean this up, thinking about it. Because doing this is kind of redundant now that I'm using the other stuff. What I'm going to do is just say meditation state dot entities dot find a a a I'm gonna make that find index rather is equal to -1. Actually, if it is found, it would be greater than -1. So basically do that everywhere else. That'll clean that bit up. And then what we need to do is work out why this issue is happening. And we're moving our player. Now that's interesting. So we've already moved there. So waiting until the next frame is not a good idea. So we have to... Oh, okay. So technically we're going to have to wait twice. Mm-hmm. Alright then. We're going to have to wait 2 frames before we can calculate available tiles. Not 1, 2. Interesting. In that case, what I'm going to do is make reset available tiles an int. That initially is going to be 2. Actually, no, it can be initially 1. So we don't need to do it. We don't need to -1 straight away. Where am I going? So if this is greater than 0, the meditation state dot reset available tiles minus equals 1, right? Else, do that. And when we go into here, we're going to say that is equal to 2. So basically what's going to happen is when we press down, this is going to be set to 2. When we go through, this is going to be greater than 0, so we -1. But we don't do this. So we iterate through this. So we're waiting for the entities to make their turn. And then by the time we go back around to this again, once we've got to -1, which would be, so it's still going to be greater than 0. Alternatively, I could just make it 1. Alternatively, I could just make it 1. That would make more sense. Let's see. Okay, we're getting somewhere. We are getting somewhere. This is looking good. I like this. We're getting there. Okay. So we wait a few frames before we do our calculation. So, let's expand this now. Let's calculate available tiles. We can expand it and actually take into account our step count. So what I'm going to do is fill this stuff in. Okay. So we're basically going to be doing this exact same thing here. So I'm going to create an inline function inside of this function. If I can do that. Can I do that? I think hacks might error out on me. Oh no, it looks fine. Alright, fair enough. Fair enough. Alright. So what I'm going to do is because I still want, the reason I want this inline is because I still want to increment result and result score, right? So that actually needs to be below result and result score so it knows what it's doing. So in here, what I'm going to do is I am going to check tile index. So we're going to say tile to check, it's an int, and I am going to do this. I'm going to cut this and I'm going to paste it in here. So our tile to check is actually this here, like that. I'm just going to paste it in all of these places where we've got an index. Now I could just do this index. Tile to check. So we will go place, no, next, replace, 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 next, replace, replace, replace. Yeah, alright. There's going to be a few errors here, so let's get rid of this bit. Oh wait, no, I didn't need to do that. What am I doing? I didn't need to do that. What am I doing? E.index, E.index, E.index. Right, we're all fixed. Good. That was a bit silly of me. Alright, so we've got this check tile index. So in here, what I'm going to do is I'm going to say check tile index is our index. Then what I'm going to do is I'm going to say for anything in our results, that is currently at the current step here. So what I'm going to do is I'm going to say var result indices equal to, and you know what? I'm going to remove that current step there because I don't want that there. And I'm going to put it outside here. So what I'm going to do, so when we do our result score, the first thing it's going to do is the current step is going to be 0, right? So if our step count is 3, so it's going to go up to 3, in which case technically it's 4 because it's 0. We're starting at 0. So we could do a +1 here to make sure it's definitely the maximum number of tiles we can go is definitely 3. So we're going to do this. And then what I'm going to do is I want to basically iterate over this result score. So I'm going to go into result score and I'm going to use this function called where. And I want to get all of the indices that match this current step, right? Which will get us back all of the indices relating to when we check the result. So, you know, these indices here, how to check. So we're going to say no, we're not. We're going to say result index in result indices, right? In fact, what I don't want to, so basically the idea behind this is I don't want to iterate over results that already exist in terms of in terms of what exists in the tiles. So if we've already matched the tile and we've already considered that tile to determine its score, then we don't want to move into that again, obviously. Doesn't really make much sense. So I want to go through all of the indices that we have already scored at the current step before we got into this step. So I'm going to write a comment here. Get all the results from the tiles that we have just assigned a score for. We only want to iterate over these and only check the tiles adjacent to it that we have not already checked. Okay. So we've got this result indices. So what we want to do is basically make sure that we do effectively check tile index again. What we don't want to do is move back into a tile that we don't want to check. So what we could do, hmm, hmm. This is an interestingly difficult problem to solve. I mean, it's not difficult. It's just working out how to manipulate this function in our favor. Okay, well, okay, so what I'm thinking is if we use the root dir that we set up for ourselves previously to determine if we can move back into, or rather, move into an adjacent cell given that that cell exists, doesn't exist within the results already. So, okay, so what I'm going to do is I'm going to say var up cell or up file up is going to be result index minus meditation grid x. File down is result index plus meditation grid x. File left result index minus 1. File right equal to result index plus 1. I understand this is probably not going to be the most efficient way of doing this. So now what I want to do is basically say can go up is going to be equal to result dot find index I is equal to tile up, because tile up is the index, right? And we're putting indices into the result. So if we can find an index that I is equal to, then if we find this and we say it's greater than -1, then we can't go up, right? So can go down, result.find index, I is equal to tile down, copy that, can go left, can go right, tile left, tile right, and then what we can then do is say, okay, if we can go up, then add that tile, right? So results dot push tile up result score dot push the current step, and then we do the same for the rest of them. So we don't actually use check tile index again. So we don't really need that function. I thought we were going to use it, but no. Tile down. Why am I doing that for? Copy, paste, paste. Can go, yeah, well, tile right, can go left, tile left. Okay. That it? Is that actually it? Kind of is, isn't it? Kind of is. Um, I'm not. Yeah, I'm not actually seeing anything wrong with this. Let's test it. Let us test. Nothing's happening. I'm not seeing more tiles to render here. I can go. Okay, so what's happening here? So we got our result score, right? 0. I is equal to current snap, right? So we get our indices, which is it's an empty array. What? Oh, because the current step is 1. Oh, of course. I'm an idiot. I'm an idiot. So in this case, we've got yeah. Okay. Oh wait, hold on. 0. Why would that be the case? Our result score is 0. Right. So we've got a where. Oh, we don't. Oh, I don't want the actual results of the score. I want to know what the index is. So if we go into here to begin with, so we've got 0, 1, 2, which is what we want to see. If we go into here then, we've got tile up, which is whatever our result index is, which is, oh, no, no, it's supposed to be that. Okay, we're almost there. There is still a few problems by the looks of it. Okay, what I'm going to do is that back up here, I'm going to make this 5 again. So that we've got a bit more area to play around and actually fix the other stuff. Where are we? Oh no, I was in here, wasn't I? Oh, that's strange. I can go down there, but I can't go up there. How peculiar. So I'm basically just copying this, right? Again, this is not optimal code. I just want to put that out there and put the emphasis on that. Right. Hopefully, this will produce the results that I'm thinking we need. Okay, that is indeed correct. That looks amazing. That is phenomenal. Now, that's good. Yeah, I'm liking this. So, okay, so technically we can move 3 times. I'm measuring it based on going twice. So it looks like I didn't need to do that +1 here. So we could go there. But we're going to leave the rest of it until tomorrow because it is getting on quite late now and I need to just pause for a minute. So in the next video, what I'm thinking it would be a good idea to do is actually be able to move our player within this area that we can move to, and then the enemy can move. So instead of moving instantly, it waits for us to change, and then we can go ahead and uh, do whatever it is that we can do, and then whatever the enemy does, etc. So I'm going to leave it there, and we will get back some more videos at a later point in time. So thank you very much for watching. Hope you enjoyed, and like I said, in the next video we'll be looking at expanding this even further. Thank you. I'll see you next time.